So now what we want to do is we want to look at some slightly more complicated radical equations. So in this case, I can see that there is a radical equation, and then there's also just kind of a polynomial on the right. So the big thing is that this is already by itself. So I'm going to work with that and see how can I get rid of this um, square root. So what undoes a square root? Well, squaring a quantity undoes a square root. So I'm going to square both sides. Okay. And whenever I have a radical totally by itself on one side, I can always take both sides to whatever that power is. So right now I got x plus 2 equals, and then I have x plus 2, x plus 2, which turns out to be x squared plus 4x plus 4 equals x plus 2. So now I have a polynomial, which I like to deal with. This is a lot easier. So I'm going to get one side to be 0, because that's what we always do when we have a polynomial equation. We always want to get one side to be 0. So I'm going to subtract x and subtract 2 from both sides. See what we have. I got 0 equals x squared, 1x squared, plus 3x plus 2. That is pretty easy to factor, so that turns out to be x plus 2, x plus 1. And that means that x equals negative 2 and negative 1. So we do want to check for extraneous solutions to see if it works out. So we're going to plug it in and see what happens. So I'm taking the square root of negative 2 plus 2. Does that equal negative 2 plus 2? Well, that's 0. The square root of 0 is 0. So that checks out. So we're going to plug negative 1 in. The square root of negative 1 plus 2 should equal negative 1 plus 2. That's the square root of 1, which equals 1. So that checks out. So let's look at another example. So this is the same basic idea. This one already has a square root already by itself. So we're going to try to get rid of the square root by squaring both sides. Now, if this was the third root, which we might see in the future, we would be taking both sides to the third power. Or if it was the fourth root, we would take both sides to the fourth power. Same old idea. So right now I got 2x minus 3, and then this side turns out to be x squared minus 6x plus 9. That's when I square that, that's what it gets. So I'm going to subtract 2x from both sides, add 3 to both sides, because I want to get one side to be 0. And I get x squared minus 8x plus 12 equals 0. So when I look at this, I think that turns out to be x minus 6, x minus 2. That's what it factors out to be. So I get x to be 6 and 2. So let's check both of them, see if any of them are extraneous or not, because that's what we always do. We always want to check to see if things work out the way that they're supposed to. So I got 6 minus 3, plugging 6 in place of x for both of these. And I have the square root of 12 minus 3, which is the square root of 9, which equals 3. So that checks out. We're going to plug 2 in. So I got the square root of 2 times 2 minus 3 equals 2 minus 3, which is negative 1. And then I got 4 minus 3. And then this is the square root of 1. Now, this is saying it's the positive square root of 1. Is the positive square root of 1 negative 1? No. So 2 is extraneous because it doesn't check out. Remember, we do plus or minus when we are square rooting both sides by some sort of value. Here, I'm only taking the square root of one side. So 2 is considered to be extraneous. 6 would be my solution.